Hi everybody, so let's go ahead and get started with our Unit 5 review part 1. The purpose of this review is to get us ready for our next exam, and I really want to target a lot of skills dealing with square root functions and inverses of square root functions. So let's go ahead and get started. So we got a couple of practice problems here that says, which of the following has an inverse that is not a function? Okay, so we're discussing two things here, inverses and functions. And so let's go ahead and work this first one out, and then we'll discuss it, right? If we have this equation here, y equals the square root of x plus 2, and I wanted to solve for the inverse of this, well, the inverse, we first know that we need to switch, right? We switch x and y. So what ends up happening is when we rewrite this, we would have it as x equals the square root of y plus 2. From there, okay, we need to solve for y. So when we do this, we have this x equals the square root of y plus 2. If I want to opposite operation, the square root, well, I need to square both sides. So I'll have x squared equals square root, and square simplify out, y plus 2. I still don't have y by itself, so what I want to do is I want to subtract 2 from both sides. And so we'll get x squared minus 2. And remember, these are two different terms, so we can't combine them. They're not alike. We get this y equals x squared minus 2. And we can rewrite that just so it's a little easier on the eyes as y equals x squared minus 2. So then we need to determine, is this a function or not? Well, there's several ways we can do this. I think the easiest way for most students is the vertical line test. And so when we discuss the vertical line test, well, we need to graph this, right? So if I was to graph this on a coordinate plane, x and my y, okay? And if I was to put this on a graph here, we know we would go 2 units down, and it's x squared, which is a parabola, and we see this happening here. Okay, so if I did a vertical line test, we would draw our vertical line, we'd come up and down, and it only touches once. And it doesn't matter where I draw this vertical line, it's only going to touch and cross that at once. So because of that, this is a function. Okay, well, I'm looking for something that is not a function. Okay, well, hint, hint. Obviously, this next one is not, but I need to prove to you why it is not. But mostly what I want you to remember is if you take the inverse of a square root function, or I'm sorry, if you take the inverse of a square root relation, like we have here, the inverse will give you a quadratic, which is a function. So again, a square root inverse will give you a quadratic, which is a function. Now, if we do the same operations on the other problem here, if I switch my x and y, and I say x equals 4y squared, and I solve for y here, so if I divide both sides by 4, I get x over 4 equals 4 over 4 simplify out y squared. I then want to take the square root of both sides. So we know that we'd have the square root of x over 4 equals square root and square simplify out y. Now, what happens here, and we can rewrite this, is a lot of times students will see this as, oh, well, I know if I graph this, that's no big deal. I can put this on a graph. If I put this into Desmos, Desmos will give me this. And let me show you what I mean by that. We'll see something very similar to this. And if I do the vertical line test, oh, it's going to be okay. Like, it's going to graph it. And that's true. But what Desmos is doing, and what it's failing to do, more importantly, is that when we have a square root of something, you have to remember that it's really plus or minus. Okay? It's really plus or minus. So if we were to graph this, yeah, we would have this blue line coming up, but we would also have this yellow. And so if we do the vertical line test, you'll see that we're actually crossing 2 times. Okay, and we can draw that again, and we're still crossing 2 times. So the inverse to this is not a function. Okay, again, this would not be a function here. So you got to be very, very careful when you're taking the inverse of a quadratic. You will not get a function. So keep that in mind. Let's go ahead and move on. Okay, so then when we're solving this one here, we're going to go ahead and rewrite this as y equals 2 square root of x plus 1 over 2. We're going to switch our x and y, so we'll have x equals 2 square root of y plus 1 over 2. We want to isolate y, right? So what we need to do is we'll multiply both sides by 2. So these will simplify out. So we'll get 2x equals 2 square root of y plus 1. From there, we'll divide both sides by 2. Simplifies out, and we can already see here that, yeah, these 2's are going to simplify out. So we're going to be left with x equals the square root of y plus 1. To reverse operation this square root, we need to square both sides. So we'll have x squared equals square root, and square simplify out, y plus 1. We'll then subtract 1 from both sides. So we'll get x squared minus 1 equals y, because 1 plus that simplify out. So we're left with the y equals x squared minus 1. And for notation purposes, we know this is really going to end up being f inverse of x equals x squared minus 1. And this is how we solve for the inverse of a function. Okay. Let's go ahead and move on. So it says, what is the sum of the solutions for the equation below? Remember, the expression inside the radical must be non-negative. Oh, okay. So we want to solve for the solutions for this. There's several ways you can do this. You can try using Desmos, other graphing calculators, but let's go ahead and work this by hand. So I want to solve this out. So first, let me rewrite this. We'll say the square root of x squared minus 10 equals the square root of x plus 2. Well, if I want to solve this, the first thing I want to do is get rid of these square roots, right? To do that, well, we just need to square both sides. And we can do that because whatever we do to one side, we can do to the other. So then we're left with x squared minus 10 equals the square root, oh, not the square root. I apologize, let me clean that up there. X plus 2. So then how do we solve this, right? Well, we want to move everything to one side. So I'm going to go ahead and kick this x over here and this 2. What we're really doing is we're subtracting from both sides. So what happens here is we get x squared. When we subtract x from both sides, we get minus x. And when we subtract 2 from both sides, we get minus 12 equals 0. Oh, well, this looks very familiar, right? Now we have a quadratic. So we have this quadratic. You can solve this using multiple methods. We can use a quadratic formula. We can try factoring, which is what I'm going to do here. I'm going to try factoring. I'm going to split this up into 2 binomials. I know x and x times x is x squared. So I got to think of 2 numbers multiplied that give me negative 12, but added or subtracted give me negative 1. Okay, I know several of us like using that X method that you guys learned, or you can use the BC tables as well. And so we're looking for -1 and -12. Well, two numbers multiplied for sure would be what, 4 and 3. And I need this -4 to be negative, right? -4 times 3 is -12. -4 plus 3 is -1. Okay. So -4 and a +3. Well, these aren't our answers yet, right? We want to solve for the solutions. To do that, we need to take each factor. So we'll take this first factor, and we need to set it equal to 0. And we do the same thing for the other factor. We have x plus 3 equals 0. So then when I solve this here, I can add 4 to both sides. So we get x equals 4. And on the other one, we subtract 3 from both sides. And so we'll get x equals -3. And so these are our two solutions. Cool. And so you're going to want to say, okay, let's go ahead and add them. 4 minus 3 is 1. My answer's got to be 1. You got to hold on. You got to stop. Wait. We need to remember with square roots, we can have what are known as extraneous solutions. Again, we can have extraneous solutions. What I mean by that is when we put these values in to the original equation, we might get wrong answers. So let's go ahead and prove that real quick to check our extraneous solutions. We're going to say the square root. Then I'm going to plug in that 4 in for x equals the square root of 4 plus 2. Well, 4 squared is 12. 12 minus 10 is 2. So square root of 2 equals, we can try this here. 4 plus 2 is the square root of 6. I'm so sorry, there's a mistake here. 4 squared is not 12, it is 16. 16 minus 10 is 6. So this works. 4 works. I'm going to confuse you guys with that. Just pause. If you have any questions, let me know. Sorry, 4 squared is 16. 16 minus 10 is 6. Square root of 6 equals the square root of 6. If we check the other solution, if we say the square root of -3 squared minus 10 equals the square root of -3 plus 2. Well, -3 squared is 9. 9 minus 10 is -1 equals the square root of -3 plus 2 is -1. So this looks like you'd be correct, right? But you got to remember what it says here. Remember, the expression inside the radical must be non-negative. This negative is no good because this leads to imaginary numbers, and that changes everything. Because -3 results in an imaginary number, it is extraneous. So our only solution here is 4. And we only have 4, so 4, it's really 4 plus 0 is just 4. So our overall answer is 4. You have to be careful. You have to check your answers. Okay? Let's go ahead and move on. It says solve the solutions for the following inequalities. So we're just solving for x. Okay, so let's go ahead and do that here. So we'll have the square root of x minus 1 plus 2 is less than or equal to 5. So what we'll do first is we'll subtract 2 from both sides. So I'm going to get the square root of x minus 1 is less than or equal to 3. We then need to square both sides. Square root simplify out. We get x minus 1 is less than or equal to 3 squared is 9. Add 1 to both sides, and we'll get x is less than or equal to 10. Done. Now what it's not asking us to do is graph it, but I'm going to go ahead and do that anyway. I think that's good practice. We can put our point here at 10. It's less than or equal to, so we're going to use a closed dot. We're talking about all the numbers that are less than, so let's go to the left. Okay. For the other one here, we've got the square root of b minus 3 plus 1 is greater than or equal to 6. Well, to solve for this, right, we're going to subtract 1 from both sides. We'll get the square root of b minus 3 is greater than or equal to 6 minus 1 is 5. We'll square both sides. Square and square root simplify out. We get b minus 3 is greater than or equal to 5 squared is 5 times 5 is 25. We'll add 3 to both sides. We get b is greater than or equal to 28. Okay, and there's your answer. We can graph this, right? We can put that on a number line. Here at 28, we're saying that b is greater than or equal to, so it'd be a solid point. And we're talking about all the numbers greater than, so I'd go to the right. Okay. Let's go ahead and move on. Last problem here. So it says, let's observe the inverse and discuss characteristics. Is the relation and its inverse 1 to 1? Are the composites equal to each other? What is the domain and the range of each? Okay, so there's a lot going on here. So let's break this down first. So we're talking about inverses. So let's first solve for the inverse. So we know that we're going to go x equals y minus 4 squared plus 2. So what I did here is I already switched my x and y. We've done inverses in this video already. So then we're going to subtract 2 from both sides. So we'll get x minus 2 equals y minus 4 squared. From here, we'll take the square root of both sides. So we want square and square roots to simplify out. So we have the square root of x minus 2 equals y minus 4. From there, we will add 4 to both sides. And we end up getting, I'm just going to rewrite it here as y equals the square root of x minus 2 plus 4. And we really should be writing this as f inverse of x equals the square root of x minus 2, and then outside plus 4. So let's talk about some of these things that we're wanting to discuss here. Is first and foremost, it says, is the relation and its inverse 1 to 1? Well, what does 1 to 1 mean? Well, we first want to discuss it as being a function, right? So let's go ahead and test out our first equation. F of x equals x minus 4 squared plus 2. So if I graph this, and using what we know about transformations, we know that we're going to go 2 units up. Actually, we should go 4 units to the right. 1, 2, 3, 4, then 2 units up, and we graph. So if I check to see if this is a function, well, we know that we can draw vertical lines. So we know that function, yes. Now is it 1 to 1? Well, 1 to 1, we have to do the horizontal line test. That horizontal line test goes side to side. And it can only touch once. Well, I'm touching once, twice. So this is it 1 to 1? That's a big fat no. Okay, not 1 to 1. So we can go ahead and cross that out. Not 1 to 1. It is a function, but it's not 1 to 1. Okay, so we've identified whether it is or it isn't. And then it says, are the composites equal to each other? Well, what does that mean, right? In other words, if we do something like this, and we've discussed composites in the past, if we said f of g of x should be equal to g of f of x. These two are composites of each other. Okay, and so for inverses, what you need to remember is that when you take the inverse of a function, you put it inside the original function, you're going to get x. And that works the opposite way as well. If you take the inverse and you put it in the original function and you work it out, you're also going to get x. And these two will always be equal. So we've discussed the inverses, we discussed one-to-one, we talked about the composites. Okay. The last part here, what is the domain and the range of each? Okay. So looking at the graphs first, we can say for the f of x, the domain, well, we know we're going all the way to the left and all the way to the right. Well, that would be all real numbers. For the range, our lowest point is at 2, so we would go from 2 to infinity. Or you could say y is greater than or equal to 2. For the inverse, okay, that inverse is, well, we have this equation here. We can graph this. Okay, if we were going to graph this, we would see that we would have to go, what, 2 units to the right. So we go 1, 2, and then 4 units up. 1, 2, 3, 4. We would be here, and we know that we go up, and we also go down, right? Because we know this is a plus or minus for the radical. So our domain for the inverse, how far left or right? Well, I don't go all the way to the left. It stops here at 2. We would go from 2 to infinity. Or in other words, it would be x is greater than or equal to 2. For the range, okay, the range here, we're going to go forever up and forever down. So that would be all real numbers. So what I want you to see here is that inverses, these two, the domains and the range, switched. And that's what happens with inverses, right? We know those x and y values are switching. The inputs and the outputs are switching. All right, guys, I know this is a little lengthy of a video. Hopefully it helps with your review. If you have any questions, message me on Teams. Have a good day, and we'll talk to you all later.